Hello, my name is Rowan Delmain. I teach grade 8 to 12 maths, and today we're going to be going over some grade 12 functions. Now this is the sort of question on functions that you can expect to find in paper 1. So the first thing we're going to do here is read our question carefully. In the diagram below, A and B are the x-intercepts of the graph f of x equals x squared minus 2x minus 3. So that's the equation of our parabola here. And they haven't given us the coordinates of our x-intercepts, but those we can work out if we're asked to. A straight line G through A cuts F at C, 4 and 5, and the y-axis at 0 and 1. M is a point on F, and N is a point on G, such that MN is parallel to the x-axis. Sorry, MN is parallel to the y-axis. So this line here is parallel to our y-axis. MN cuts the x-axis at t. 6.1, we're asked to show that g of x is equal to x plus 1. So let's start off with the general equation of a straight line, which is y equals mx plus c. The m value in our equation tells us what the gradient of the straight line is. And the gradient we can calculate using the formula m equals y2 minus y1 over x2 minus x1, if we know the coordinates of two different points on our line. And the c value tells us our y-intercept. So we need to calculate these two values to determine the equation of our graph. Now if we look here, we know that our y-intercept is 1. So straight away we know what our c value is. That's going to be 1. So we know that y equals mx plus 1. Now, to work out our m value, there's two different ways we can do it here. We can either use our formula, because we know the coordinates of two separate points on our graph. We know these coordinates here, and we know these coordinates here, which are 0 and 1. So we can substitute those coordinates into our formula. Y equals 5 minus 1 over 4 minus 0, in which case it becomes 4 divided by 4, which equals 1. That's the one way we can calculate our gradient. Or we can take the x and the y values here that they give us, substitute them into our equation for x and y. So y we can change to 5, x we can change to 4, and then we solve for m. So then this will become 5 equals 4m plus 1. Move the 1 over onto that side. 5 minus 1 equals 4m. 4 equals 4m. So 1 will equal m. So now we know that the equation of our straight line is going to be y equals 1x, or just x, and then our y-intercept, which is 1, so plus 1. And there's our answer for 6.1. Now for 6.2, we're asked to calculate the coordinates of A and B, which are the x-intercepts of our parabola. So we're told that the equation of our parabola is f of x equals x squared minus 2x minus 3, which we can also write as y equals x squared minus 2x minus 3. Now we know what the y-coordinate of each of these points are. Because they fall on the x-axis, the y-coordinate is going to be 0. So each of these is going to have an unknown x-coordinate, which we don't know yet, and our y-coordinate is 0. So how we going to calculate our x-coordinate is we're going to substitute y for 0, because we know what our y-coordinate is there. And then we're going to solve for x. And we're going to solve for x by factorizing. So we're going to have two brackets. The first term in each bracket is going to be x. And then we want to look at the factors of our last term here, that if we add them together will give us our middle term. So that is going to be -3 and +1. And there, if you check it, -3 times by 1 gives us -3. -3 plus 1 gives us our middle term of -2. And then for each of these we're going to solve for x. X minus 3 equals 0. X plus 1 equals 0. X equals 3. And x equals -1. And that is going to be our x coordinates of a and b, 3 and -1. So for our final answer, the coordinates of a is going to be, and I see I got these the wrong way around. This one is -1 and this one is 3. So our coordinates of a are -1 and 0, and our coordinates of b are 3 and 0. And that there is our answer for 6.2. Now for our next question, we're asked to determine the range of f. Now what the range is of our parabola is it's all the y values that our parabola falls between. So we need to calculate our lowest point there, which means that our parabola falls between all the y values from that point going up to infinity. So to calculate our y value there, we need to calculate the y value of our turning point. And how we do that, we're going to use our turning point equation to work out the x value. X equals -b over 2a. Now the general equation of a parabola is y equals ax squared plus bx plus c, which is where we get our b value and our a value to put into our turning point formula. So if we look at the equation they give us for f of x equals x squared minus 2x minus 3. The coefficient of our x squared, which in this case is 1, is going to be our a value, and our b value is going to be -2. So we're going to substitute that into our turning point equation. So x is going to be -2 divided by 1. And because we're minusing a negative, it's going to become +2. So now we know what our x coordinate of our turning point is. It's positive 2. Now to work out our y coordinate, we can take this value and substitute it into our original equation for f of x, now that we know an x value, and we can solve for y. So this is now going to become y equals 2 squared minus 2 times by 2 minus 3, which will be 4 minus 4 minus 3, which means our y value is 4 minus 4 is 0, minus 3 is negative 3. So our lowest y value of our graph is negative 3. So all the y values our graph falls between, which in this case is our range, is any y value greater than or equal to negative 3, and we write that as y is greater than or equal to negative 3, and that's our answer for 6.3. Now 6.4.1, we're told that the length of MN is 6 units. And then we're asked to determine the length of OT if t lies on the negative x-axis, which we can see on our graph. Show all your working. So the length of MN is going to be the difference between f of x and g of x. And in mathematics, difference means minus. If you work out the difference between two things, you subtract them from each other. So what we're going to do here is we're going to subtract g of x from f of x. And we do that to calculate the length, and they've already told us what our length there is. It is 6 units. Now we know what our equation of f of x is. So we can substitute that in there. And we know what our equation of g of x is. We already worked that out in 6.1. So we can just substitute our two equations into our formula there and solve for x. So f of x is x squared minus 2x minus 3, and then we're going to subtract g of x, which is x plus 1, and then make it equal to 6, and then solve for x. Now here what we want to do is make this into a trinomial so that we can factorize it. So we've only got one x squared, negative 2x minus x is negative 3x, negative 3 minus 1 is negative 4 equals 6. And then we're going to bring the 6 over onto this side. X squared minus 3x, negative 4 minus 6 is negative 10 equals 0. And then we want to factorize this. So we're going to have two brackets, x and x, and the factors of negative 10 that if we add them together gives us negative 3 is negative 5 and positive 2. And then if we solve for x, we end up with x equals 5 and x equals negative 2. Now we're asked to determine the length of OT, which means we need to know what the x coordinate of t is. And what we've done here is we've calculated our x coordinate. So we've got two x coordinates here and a positive and a negative x coordinate, and we want a negative x coordinate. So we know that our x coordinate of t is negative 2, which means that the length of OT from O to t is just going to be 2 units. And that is our answer for 6.4.1. For 6.4.2, we're asked to write down the coordinates of n. Now in the previous question, we calculated what the x coordinate of n is. It's the same as the x coordinate of t, which is negative 2. And n lies on our straight line graph, which we know the equation of from 6.1. It's y equals x plus 1. So to calculate the y coordinate of n, we know what the x coordinate is. It's negative 2. So we can just substitute that in there and then solve for y. And negative 2 plus 1 is negative 1. And that's going to give us our y coordinate of n. So our final answer, the coordinates of y is negative 2 and 1. For 6.5, we're asked to determine the equation of the tangent of f drawn parallel to g. So that means we're going to have a line that looks something like that. That's going to be parallel to g. Now if two straight lines are parallel, that means they share the same gradient. And we know that g of x, the equation of g of x is, we worked it out in 6.1, x plus 1, which will tell us that our gradient of g is 1, which means the gradient of this tangent here is going to be 1. So straight away we know that if we look at the equation of our straight line in the form of y equals mx plus c, we know what our m value is. So it's going to be 1x plus c, or just x plus c. So now we need to calculate our c value. Now usually to calculate that we need the coordinates of any point, but we're not told what the coordinates of any point is here. So what we're going to need to do is calculate the point at which this tangent and our parabola touch. And to do that we're going to use calculus. Now according to calculus, if you calculate the derivative of a parabola f dash x, that gives you a general equation for your gradient. Now we already know what the gradient of this line is, so we can calculate our derivative and make it equal to 1. And then we can solve for x, and that'll give us the x coordinate of the tangent to this line that will have a gradient of 1. So we know that f of x, the equation of our parabola, is x squared minus 2x minus 3. So our derivative of that is going to be 2x minus 2. So we're going to substitute that into our equation here. 2x minus 2 equals 1. And then we're just going to solve for x. You bring the negative 2 over. We have 2x equals 1 plus 2, which is 3. And x equals 3 over 2. So that's going to give us our x coordinate of this point over here. And then to work out our y coordinate, we're going to substitute that into our parabola equation. So y equals x squared minus 2x minus 3. And we know that x is 3 over 2. So we're going to substitute that into our equation and solve for y. Three over 2 squared is 9 over 4. Negative 2 times by 3 over 2 is negative 3 minus 3. Negative 3 minus 3 is negative 6 times by 4 is 24. So this will be 9 over 4 minus 24 over 4, and y, 9 minus 24 is negative 15 over 4, which is going to be our y coordinate, negative 15 over 4. So now we know what our gradient is, we know what our y-intercept is, so the equation of our tangent here in the form of y equals mx plus c is going to be y equals x minus 15 over 4. For our final question, 6.6, we're asked for which values of k, or h of x equals x squared minus 2x minus 3, and h of x equals x plus k not intersect. Now if you look at our straight line equation they give us here, h of x equals x plus k. We don't know what our k value is. That's going to be the y-intercept of the straight line, but we know that our gradient here is 1, which means that it's going to have the same gradient as this tangent that we worked out in our previous question. So they're asking for what y values will they not intersect. If we were to move this tangent up at any point past this y value here, it will intersect with our parabola. But if we move it down at any point lower than our y-intercept, then it won't intersect. So therefore the answer for this question will just be k is any value that's less than negative 15 over 4. Thank you for watching this video. I hope you've learned from it, and good luck for your exams.